A very warm welcome, everyone, to the Maritime Education Podcast. My name's Barry Sadler, and to those of you returning to the podcast, welcome back. And if you're new, I hope you find something in these podcasts entertaining and educational, particularly those of you who are, of course, studying for a certificate of competency. Today, I want to talk about some of the realities, really, of complying with the requirements of MARPOL, and in particular, the requirements of MARPOL with regards to Annex 6 and the implementation of emission control areas. I particularly want to concentrate today on ultra-low sulphur fuels. Now, let me give you some background as to why I thought this would be an interesting podcast. At the moment, on some of our largest container ships coming to and from Southampton, we've got pilots who are tripping to learn how to effectively handle these container ships and become a container ship VLS pilot. Once authorized, this will allow them to pilot the biggest container ships in the world as a what we call VLS pilot, very large ship pilot, and therefore, when one of these size vessels rocks up at the pilot station, a VLS pilot is chosen from the pool of on-watch pilots to conduct the vessel, that way ensuring that they have the necessary training, experience, and ability to bring in the biggest container vessels in the world. So I was designated an inbound container ship a couple of days ago. The inbound container ship was a fairly standard, what we call Category 2 container ship. This is a container ship that was approximately 300 meters long and approximately 40 meters wide. This size of container ship are regularly plying the trade now across the Atlantic, in between the US and Europe. We boarded this container ship in the regular boarding position, and we went up to the bridge, and the trainee pilot started to do the master pilot exchange. I always like to try and take a step aside when the master pilot exchange is happening between a trainee and the master, because I like to see how the trainee deals with the questions that the master may have about the intended act of pilotage, and just to see what the dynamic is really between the two of them as they exchange the vital pieces of information that they are required to exchange. So the draft of the ship, the route that they're going to take in, how many tugs they're going to use, what the expected weather conditions are, which berth they're going to, whether the vessel's going to swing or go straight into that berth. These are all items that must be discussed at the master pilot exchange. So I take a step aside and I let the guys get on with it so I can feedback to the trainee as to how they did with that master pilot exchange. But I also like to see the dynamic from a professional point of view. It's always good sometimes to stand back and watch two people interact. You can see how the dynamics between them and how they accept one another, really, because the master's never met the pilot's never met the master, but one of the amazing cognitive skills of a pilot is to form a really important working relationship with the master within a matter of seconds or minutes. And that's what I'm looking for as I stand back and I watch the trainee engage. The captain then said something to the trainee which perturbed me a little bit. The captain said, "We may not be able to achieve dead slow ahead." Now, this ship had a very, very small range of revolutions between dead slow and full ahead. Basically, dead slow ahead was 22 RPM and full ahead was 38 RPM. So in between the slowest available speed and the highest available maneuvering speed, we've only got some 16 revolutions. So basically, it goes up in between 4 and 6 RPM from dead slow to half to full until you get from your 22 RPM at dead slow up to your 38 RPM at full ahead. Now, the master said that he was able to achieve 48 RPM without too much notice to the engine room, and that would give us around 15.5 knots, which was an adequate speed for the purposes of coming in that morning. So we weren't too concerned about giving notice about the engines, but what I was concerned about was the master's comment to the trainee that he may not be able to achieve dead slow ahead. I let the trainee absorb this and deal with this and question the master further as to why this was the case. And the master seemed to be very, very vague with his description as to why dead slow ahead was not achievable. The main reason he gave was that when we set dead slow ahead on the engine, the revolutions start to cycle. So the engine struggles to maintain a constant RPM at dead slow ahead. And although it won't stop, it will cycle from about 20 RPM to about 26 RPM, and it can't maintain the steady 22 RPM that the dead slow ahead speed of the pilot card gave. So we took this on board. Slow ahead was only, I think, 4 revs more, so we could go to slow ahead and perhaps still achieve the same requirement of power in order to handle the vessel. But nonetheless, we were faced with some form, really, of defect with the ship. If the captain is saying that his engine was unreliable at dead slow ahead, that's something that needed noting. And noting it, we duly did. We decided to proceed. This isn't a showstopper. This is just something we needed to be aware of. I did let the trainee pilot explain to the master that this kind of restriction should have been made known to VTS when they reported, but nonetheless, it wasn't an engine failure. It was a particular problem at a certain RPM. So jointly with the trainee pilot, we decided that it was safe to proceed. One of the things about pilotage is that the longer you're on the bridge, the more the captain gets to know you. And the more the captain gets to know you, the more the captain will open up about life on board the ship, technicalities of the ship, and in our case, open up a little bit more about why he was struggling to maintain the dead slow ahead. Once the trainee pilot had got into the act of pilotage and was driving the ship, I sidled up to the master and I asked him a little bit more about this dead slow ahead issue that he had. I pointed out to him that I considered it a defect, because if he can't maintain the revolutions advertised on his pilot card, then this is something that the pilots before they boarded the ship should have known. And I gently reminded him that if it happened in future, that he needs to declare this to the port on his approach so that we can come with that information to the ship and make any adjustments to our passage plan necessary to take account of this fault. When I pushed him further as to why he thought it happened, he was telling me of his struggle to be able to use marine gas oil as opposed to ultra low sulphur fuel oil whilst he was in Europe. Now, he said that the use of ultra low sulphur fuel oil hampered his injectors. It made his injectors clog up, and this is what gave us this fluctuation in the revs at slow speed. The fuel is moving through the injectors at a much slower pace than it would be if the engine had sped up, and therefore this slow-moving fuel would deposit sludge-like substances within the injectors and would block the injectors. And it was this fluctuation of the revs that was a result, really, of this gloopy product going through the injectors. So I thought to myself, well, why are there two options here? At the end of the day, this master is operating in an emission control area. So the North Sea under MARPOL Annex 6 is an emission control area, and therefore the maximum sulfur content of your fuel oil in this area is, of course, 0.1% sulfur. So the master was using ultra-low sulfur fuel oil, which by its sheer name is ultra-low sulfur fuel. i.e. it's at the 0.1% sulfur, maximum 0.1% sulfur, required by MARPOL Annex 6 when the ship is operating in an emission control area. No scrubber on the ship, so there was no way of using higher sulfur fuel oil and then scrubbing the emissions in order to bring it to the equivalent of using an ultra-low sulfur fuel. So the ship had to burn the correct sulfur fuel for the area in which they were operating. So once again, North Sea Emission Control Area, 0.1% sulfur cap, and that's what the fuel should be. So ultra-low sulfur fuel is 0.1%. But marine gas oil is also at 0.1% sulfur. Now, there is a really big difference between marine gas oil at 0.1% and ultra-low sulfur fuel oil, which is 0.1%. The big difference is that marine gas oil is 100% distillate. In other words, it is a highly distilled fuel oil. It's like a very, very high-grade diesel. It's clearer, it's lighter, it's less thick, it's runnier, if you like. The density is much lower than that of ultra-low sulfur fuel oil, and therefore it tends to work much better in engines. Why? Because it's thinner, it doesn't need so much heating up. Because it doesn't need so much heating up, then there's less maintenance that goes into the oil going into the engine in the first place. And because it's thinner, it runs through the injectors much better, leaving less deposits on those injectors. Ultra-low sulfur fuel oil is generally a blend of distillates and low sulfur residuals. In other words, it is pretty much bottom of the barrel stuff that has been refined to simply remove the sulfur from it. Now, what we end up with is a considerably cheaper fuel blend than MGO, but to burn it correctly, you've now got to really heat up ultra-low sulfur fuel oil. You've often got to get it up to somewhere between 40 and 60 degrees Celsius. It becomes thin enough for the fuel injectors of an engine to take. This basically makes it more compatible with engines that were designed for heavy fuel oil. In other words, if your engine was an older engine designed to take heavy fuel oil before these kind of sulfur limits were taking effect, then your engine fundamentally can handle this ultra-low sulfur fuel oil better. The ship that we were on had come from the United States, and although ultra-low sulfur fuel oil, be it cheaper and be it better to use on engines designed for heavy fuel oil, there's not much of it on the east coast of the United States. In fact, it's seen as a specialist product over there. So most of the oil that you're able to bunker over there, particularly on the east coast of the United States, is MGO. Okay, the thin stuff that flows easily at room temperature. What then happens, of course, is that the ship is in the States, the ship bunkers in the States, it bunkers MGO because ultra-low sulfur fuel oil either isn't available or is seen as a specialist product and therefore overpriced. So the ship will normally bunker MGO and it will come across the Atlantic on marine gas oil pretty much until it gets to Europe. When it gets to Europe, ultra-low sulfur fuel oil is much more readily available, particularly in places like Rotterdam and Antwerp. And the ship that we were on had recently gone to both. So they were able to bunker ultra-low sulfur fuel oil at a lower price and still meet the 0.1% sulfur limit that MGO met, but we're now bringing on board a much thicker fuel than the MGO. So now imagine it, the ship has run across the Atlantic using MGO. The thinner oil has had less deposits being placed inside the injectors, and the ship has run absolutely fine. But it's cleaned out a lot of those deposits that sometimes make both the injectors and the engines a little bit more reliable. Switch when you get to Europe to ultra low sulfur fuel oil, mainly, of course, because it's cheaper and it's readily available. And now, although your engine is designed to work with heavy fuel oil because it's old, you're now working with a much thicker, stodgier product, and therefore your fuel injectors then start to accumulate more gunk within them. This MGO can cause scuffing or excessive wear on fuel injection pumps because MGO is so thin, whereas ultra low sulfur fuel oil contains residual oil components, so it's naturally better at lubricating things like injectors, but it often leaves this stodgy deposit upon them. The other thing about ultra low sulfur fuels is they can be chemically unstable because they're often a designer blend of different refinery streams. Mixing it with other fuel oils like heavy fuel oil or certain MGOs can cause it to become incompatible, leading to the heavy sludge that can clog filters and stop the engine if you combine these oils together and they become chemically unstable. Now, we do have the cost thing, obviously. As I've mentioned before, ultra low sulfur fuel oil readily available in Europe and much cheaper than MGO, which of course is the most expensive. MGO is touted as plug and play, so you can take on MGO and pretty much run it through any engine without the need for any kind of heating up, but you do pay extra for this as a result. Now, both the US and the EU, the legislation, and I include the UK when I say EU, so both the US and Europe, the legislation specifically requires 0.1% sulfur, 0.1% or less. So both fuels are legally burnable within both US and European waters. So it's not as if we need one over the other to be compliant. Both fuels are compliant. At the end of the day, a lot of it comes down to cost. Now, the availability of these oils across the world really has changed, but in particular, it's changed in Europe. And of course, the reason for that is because on the 1st of May this year, 2025, the entire Mediterranean Sea became a sulfur emission control area. So the Mediterranean Sea now requires fuel oils that are less than 0.1% sulfur, if of course you don't have a scrubber, to be burnt whilst the ship is operating in the Mediterranean. So particularly in Europe, Europe has seen a lot of MGO going out to ships that are going down to the Mediterranean, particularly ships that bunker in hubs like Algeciras, Piraeus and Malta. They're getting MGO, whereas ultra low sulfur oil tends to be available in the northern European ports like Antwerp and Rotterdam, and that's why we've seen so much more ultra low sulfur fuel oil here in northern Europe, because MGO has gone down to the Mediterranean to fuel the ships in the Med, or in order for them to comply with the new 0.1% cap that came in May of this year. Now, even though there are no differences between the fuel when it comes to compliance within the States and Europe, it is worth noting that California does not like ultra low sulfur fuel oil. California specifically requires marine distillate fuels to be used, so you can't use ultra low sulfur fuel oil in California, even though it complies with the 0.1% sulfur cap. Little interesting thing I found out there whilst doing the research. So if you're going from the west coast of the States through the Panama Canal and back to Europe, then you really are reliant on marine gas oil in order to do that. So if a ship is traveling from Europe to New York, it can use ultra low sulfur fuel oil the whole way. But if that same ship is going to Los Angeles, then obviously it's got to have MGO in the tank specifically for the transit through Californian waters. And that's a complication that chief engineers would have to do it. Price-wise, marine gas oil currently retailing somewhere between $585 and $615 per metric ton, whereas ultra low sulphur fuel oil is retailing at the moment $495 to $515 dollars per ton. Now, because it's cheap and because it is available in Europe in measured quantities, it's not overly available in Europe. Europe doesn't have a glut of this oil, but it is available in Europe. It's mainly based on contract supply only, which is interesting. So your MGO has gone down to the Mediterranean, leaving lots of ultra-low sulphur fuel oil up here in Northern Europe. But even the amount that we've got in Northern Europe normally requires ship owners to have a contract-only delivery of this fuel oil, meaning that it's not there on demand to a ship owner should they suddenly find themselves short of fuel oil. If we look at a medium-sized ship burning around 20 tons of fuel oil per day, basically you're looking at a $2,000 per day saving by burning MGO over ultra-low sulphur fuel oil. Sorry, the other way around, burning ultra-low sulphur fuel oil as opposed to MGO. Ultra-low sulphur fuel oil being cheaper, and it's around £2,000 saving per day. So if you say 5 days across the Atlantic, then at the end of the day, that's a £10,000 saving on a very, very small container ship. Now, the savings can go well over 50, going up towards 100,000 per voyage, the bigger the ship is. So it is worth bearing in mind that most ship owners are driven by price, and ultra-low sulphur fuel oil is much cheaper. So that's the background behind what the master was saying, in that his engine was absolutely fine in the States. It was fine across the Atlantic when he was burning marine gas oil at 0.1%. But once he had bunkered ultra-low sulphur fuel oil in Europe and was burning that at 0.1%, the stickiness in his injectors caused the engine to fluctuate at dead slow, and that's what he was bringing to our attention. Now, after all of this this discussion, when we finally got the ship into the docks and started to go towards the berth and asked the captain for dead slow ahead, we set dead slow and the engine went to 22 RPM and it was incredibly stable. The master raised an eyebrow because he didn't expect that. He expected the fluctuation to happen, but it didn't happen. Now, he said that was probably because the engine was used to burning ultra-low fuel oil because of the passage between Rotterdam, Antwerp, and hence Southampton. The engine had been burning it for some time and had got used to the higher viscosity and, more importantly, he said, used to the higher temperature of fuel. Your injectors can suffer thermal shock if you suddenly start putting hot fuel through them. And that's something that may have been experienced in Antwerp and Rotterdam, where the revs were fluctuating. Some of it may be down to thermal shock because of the change of temperature of fuel oil being used, as opposed to the thickness of the fuel oil itself. But nonetheless, still an interesting conversation to have with a captain. I admire the master for engaging in conversation and for taking the time to explain why his ship was having to use a fuel that ultimately causes injectors to clog up a little bit. Didn't happen on the occasion when we were on the ship, and indeed the ship was berthed rather well by the trainee, starboard side to the berth, without any problems with the engine, and there were no issues at all at dead slow, and dead slow was selected on numerous occasions, particularly on our passage, of course, through the docks of Southampton towards the berth. So all in all, the engine itself performed well on ultra-low sulphur fuel oil. So the owner's going to turn around and say, well, it's cheaper. It's cheaper by £2,000 per day. That's why I like to use it when you're in Europe. And it doesn't really give us any kind of maintenance or reliability issues, which, if Southampton's arrival the other day is anything to go by, is, of course, absolutely spot on. So the master really is given the oil by the owner. The master doesn't choose whether or not to use MGO, or ultra-low sulphur fuel oil. The master must, of course, ensure that the fuel oil is compliant. So he must ensure that the fuel oil that he or she is burning is fully compliant with the emission control area that you may or may not be in. So the master has an obligation to ensure that regardless of whether it's MGO or ultra low sulphur fuel oil, that it's at 0.1% sulphur without a scrubber. This is, of course, done at the time of taking the bunkers, when the chief engineer will get 2 samples of the fuel oil and ensure it's tested to make sure that it is indeed as per the spec given to the ship in what we call the bunker delivery note by the fuel supplier. That bunker delivery note will stipulate the amount of sulphur in the fuel at a particular temperature, and that's what the chief engineer would quickly test, and what you would send a sample off to a lab to do a thorough test on to make sure that it's fully compliant. As long as it's compliant, the master is fully compliant and following the law by burning 0.1% sulphur fuel. But the master doesn't get to choose what type of 0.1% sulphur fuel. Hence, on this particular ship, the master's doubt that perhaps dead slow was going to be a little bit unreliable because of the type of fuel that he was being forced to use in Europe. A fully compliant and safe fuel that just didn't work well with his injectors. But as it happened, as I say, everything as we berthed the ship worked perfectly, and the dead slow range was within tolerances. Hopefully you found this podcast interesting. I find it interesting when you think about compliance as a master, in that the fact that compliance isn't straight 0.1%. Fuel is a different type, can be different grades, and that may be out of the control of the master. It's up to the master to bring to the attention of anybody that is involved in the navigation of the ship, but in particular, bring to the attention of a pilot that the use of these fuels may cause the main engine to act in a strange way, and therefore may prevent the pilot from observing, shall we say, an engine with steady RPM. I've been on ships with fluctuating RPMs at lower revs, and it makes the ship vibrate. The ship cycles, if you like, as the revs go up and down, which isn't good for anything in the engine or connected to the engine, such as the shaft or the propeller. It makes the ship vibrate, which of course puts stresses on the structure of the ship. And whenever you see revs bouncing around, you always wonder as per the reliability of the engine. And that's why, as pilots, we are exceptionally sensitive to engines that do show these signs of not being able to be operated at a constant RPM. We're making this podcast on Monday, the 22nd of December. So it just leaves me to say, I hope you all have a wonderful festive period. If you're at sea, please do have as best Christmas as you can, away from home and loved ones. And we are, of course, thinking of you in the maritime industry and your service afloat during this festive period. So thank you very much to all of those of you that are at sea. And to everybody who listens to the Maritime Education Podcast, Merry Christmas. And may I take this opportunity of wishing you all a prosperous and healthy 2026. Thanks a lot, guys. Have a great day, and we'll see you again soon on the next podcast on the Maritime Education Podcast. Thank you.